Screening thousands of abstracts by hand is a common bottleneck in systematic reviews. This AI tool acts as a second screener, reading abstracts against your criteria to help you move faster and catch potential mistakes without ever replacing human oversight. Before the details, here is the whole thing in 6 steps. You screen and export your abstracts from Covidence or Rayon. You build a simple spreadsheet. You publish that sheet so the computer can read it. You set up the computer, which is a one-time job we have already done. You run the screener, and you get back a finished sheet with the decisions. Steps 1 through 3 and 5 through 6 you repeat for each new review. Step 4 you basically never touch again. Do not worry about memorizing this. We will walk through each one. These are the things to have ready before you start. The lab Windows PC, which already has everything installed. A Google account, so you can put your spreadsheet online. VS Code, which is just a free program we use to run the code. Your export file, the abstracts you pulled from Covidence or Rayon. Your inclusion and exclusion criteria, the rules your review already agreed on. And the screening code itself, which you will see is easy to get made for you. That is the full shopping list. A key advantage of this setup is that it runs entirely on your local machine, not on the internet. Using a program called Ollama, the AI processes data privately. This ensures your study data remains secure and the results stay consistent and reproducible. Step 1. Get your abstracts out of Covidence or Rayon. Both let you download your screening set. Open your review and find the area where all the records are listed. Export them in a spreadsheet-friendly format, which usually means CSV or Excel. The only columns you truly need are the article title and the abstract. If the tool lets you also include the human include or exclude decision, grab that too, because later you can compare what the people decided with what the AI decided. Everything else in the export is fine to leave in, it gets ignored. Step 2. Open that export in Google Sheets and tidy it up a little. Name your columns clearly, something plain like title and abstract. Make sure there is one article per row, with its title in the title column and its abstract in the abstract column. Delete any blank rows or rows with no abstract, and leave everything else alone. Extra columns like authors or year can stay, they simply get skipped. One small tip, keep the text plain. If some abstracts have leftover web formatting in them, do not worry, the program cleans that out automatically. Step 3 is the one that feels technical but is really just a few clicks. The program reads your data from a web link, not from a file on your desktop, and Google Sheets makes that link for you. In Google Sheets, go to File, then Share, then Publish to Web. Pick your tab and choose the comma-separated values option, the one labeled CSV. Click Publish and confirm. Google hands you a long link that ends in output equals CSV. Copy that link. You will paste it into the code in a moment. One privacy note. A published sheet can be read by anyone with the link, so only publish titles and abstracts, which are already public anyway. When you are done screening, come back here and click Stop Publishing. Step 4 is the one-time setup, and on our lab PC, this is already finished, so most of you will never do it. I am showing it just in case we ever set up a new machine. You install Ollama, which is the engine, from its website. You download the GPT-OS model once, and it stays on the computer. You install VS Code, the free program from Microsoft where you run the code. And the first time you open a script, VS Code offers to add Python. You just say yes. After this, you skip straight to step 5 every single time. Step 5. And this is the part people are most nervous about. You do not write any code yourself. You ask an AI assistant to write it for you, in plain English. You paste in your full inclusion and exclusion criteria. You tell it the rule. Include an abstract only if it meets all the inclusion criteria, and exclude it if it hits any exclusion. You add the safety rule. When in doubt, include, so a human can review it. And you tell it what you want back. Read my Google Sheet link and save a new sheet with a decision and a short reason. The box on the right is an example you can copy almost word for word. That is genuinely all it takes. Step 6. Now you actually run it. And this is just a few clicks. First, make sure Ollama is on. It runs quietly in the background once the PC has started it. Open the script in VS Code and paste in your published sheet link where the code asks for it. Then press the Run button at the top right, or right-click and choose Run Python File. You will see a log like the one on the right, printing one line per abstract. A 1 means include, a 0 means exclude, and the little triangle means it disagreed with the human decision. Then you let it run, and go do something else. You do not need to understand the code to trust it, but here is what it is doing, so it is not a black box. For each abstract, it does the same 4 things. It picks up one abstract, the title and the text. It shows that abstract to the AI, along with your criteria. It gets back a decision, include or exclude, with a short reason in plain words. And it writes that answer down, before moving to the next one. Then it just repeats, thousands of times, on its own. A few thousand abstracts take a few hours, and you do not have to sit there watching. Step 7. The payoff. When it finishes, you get a new spreadsheet. Each row has the study title, the AI's decision, a short reason for that decision, and a flag showing whether the AI and your team disagreed. Here is how to actually use it. Sort by that disagreement flag. Those rows, where the AI and the human disagreed, are the only ones that need a person to look again. A senior reviewer settles each of those without being told which vote was the AI's, to keep it fair. Everything they already agreed on is settled. That is where almost all of the time saving comes from. 4 rules that keep the results trustworthy. First, when in doubt, include. We set the AI to keep borderline abstracts, because a wrongly kept study only costs a minute at full text, while a wrongly dropped one is gone for good. Second, always keep a human. The AI is a second screener, never the only one. Third, judge the disagreements blind, so whoever settles them does not know which vote came from the AI. And fourth, clear criteria win. The AI does its best work when the rules are concrete and objective, and it struggles when they are vague or subjective. A few things might go wrong, and they all have quick fixes. If nothing happens or you get a connection error, a llama is not running. Open it from the start menu, wait a moment, and try again. If every row comes back empty, the link probably is not public, so redo publish to web and copy the fresh link. If it cannot find the abstracts, your column is named something unusual. Rename it to title or abstract. If it feels slow, that is normal. A few thousand abstracts take a few hours. And if the decisions look too strict, remind the AI of the when in doubt, include rule and run it again.